I hope the screen is visible. Yeah, hi everyone. So, what sort of new things you have learned, uh, in the first half, guys? Anyone who wants to share before we start our next session, like next half? Any new things, any new examples that you foundations of ML? Yeah, foundations of ML. So, meanwhile, what more things you guys know? Yeah, what is ML, types of ML life cycle, algorithms? Yes, absolutely, absolutely. Uh, Manish, about what is machine learning and life cycle? Yeah. So, in the first half, one of the person, like I don't remember the name, like he was asking these days AI, it is booming low, so how to cope up? So I said like there is only one way to cope up. Is he present right now? I don't remember the name. So there's only one way to cope up, guys. And uh, the thing is study, nothing else. No shortcut. ठीक है? So let's revise few things. So as I told you guys, so so we have covered five things. We have completed the introduction. We have completed the things. So let me start the
Recording in
recording.
progress.
Okay. So, okay, welcome to the second half, everyone. And meanwhile, others are also joining. So let's start revising the stuff that we have completed in the first half. So we have completed the introduction to machine learning. Like we have gone through this Venn diagram. We have gone through some of the examples like this. It's an example of supervised machine learning. And then, you know, we have gone through some why do we need machine learning? We have gone through like how machine learn, how machines learn. Then we gone through the life cycle of machine learning, like from data gathering, the data preparation, the data wrangling, that is nothing but feature engineering, then analysis, data analysis, then train model, test model, and deployment. So all these things we have covered, right? Yes. So then we have understood some supervised, unsupervised, and reinforcement learning. Okay. And how it works, like the basic crux we have understood. And then we started little bit deep diving into it. Like we started deep diving into the supervised learning. Then we started deep dive into like how what is the flow of supervised learning. Like it splits the data, training and test, then we train it, then we evaluate it on test data, and then we train a model and we deploy it. Then we have understood the types of supervised learning, that is regression and classification. Integration, we have somewhere we have discussed about linear regression, logistic regression, and we have discussed about the classification as well. We have understood about these two examples as well. Okay, where there is one temperature we are predicting for tomorrow, and we are predicting also the house prices for the next year. So all these things we have covered and discussed. Nice. Yes. So then we have tried to understand to what is unsupervised learning, without how basically like any model can learn without uh, explicitly learning example, uh, without any labels and all. So how it learns, what sort of attribute it covers. Okay. So, and then we, gone through this clustering examples. Okay. And then we were discussing about dimensionality reduction techniques. Okay. So this is what we have done. Now we will discuss about dimensionality reduction techniques later on, because we have the total dedicated uh, you know, time for this dimensionality reduction technique, because this dimensionality reduction technique here, it is like, it is a type of supervised learning. But dimensionality reduction technique is a separate topic when it comes to evaluation of or training of machine learning model. It's not like, but means it's like a recursion topic. Okay. Do you know recursion, guys? Can anybody tell me what is recursion? Can anybody tell me what is recursion? What is recursion? This dimensionality reduction techniques is like a recursion. I'll tell you how, but what is recursion? Hmm. Function call itself. Yes. Like a loop. Hmm. Not exactly a loop, but like a loop. Yes. Good. Good, Nirmal. Good, Poojan. Good, Vishist. Yes, Sahil. Good one. Good one. Prushangi. Okay. Okay. So now let's start, guys. Let's start our second half. I hope you guys are excited to learn something more about the different stuff or related to the evaluation matrices, some training, and some different things. Okay. Chalo. Okay. So dimensionality reduction technique we have understood. Okay. So dimensionality reduction technique, there are so many techniques. Okay. One of them is PCA, principal component analysis. Okay. What is PCA? Principal component analysis. Okay, so I can see some questions. One question. Tejas is asking one question. In supervised and unsupervised learning slide, the animal example. Okay. Okay, let me take you guys to that example. Mm, supervised and unsupervised. Uh, okay, Tejas, are you talking about this slide? Okay. So the question is like, what if the animal is same looking, then how will the model learn? Like dog and wolf. Okay. So if you are just directly giving the images, if you are just directly giving the images, yes, it's a challenge. Because I don't know like whether you know or not, but dogs are also coming from the same genetic material from wolf only. Okay, if you don't know, so basically dogs are wolves coming from wolf. It's just like cat is lion somewhere, somewhere in genetic tree. So, so yes, in these cases, it is little bit typical to analyze whether this particular animal is dog or a wolf, uh, leopard or lion, no, leopard or you know tiger. Okay, yeah, cheetah, cheetah and leopard means this creates a huge confusion. But if I talk about supervised learning or unsupervised learning, if I talk about the machine learning, not deep learning, in that case, it's easy. Okay, it's easy to classify. Okay, it's easy to classify. Why? Because we have examples. Okay, because why? Because we have proper data with all the attributes, with all the differences. Means, see, I know dog and wolf coming from the same genetic material, same genetic tree, but still they do have differences. We know that as a human, and we will put that difference in the table in thousands and crores of data points, and then we will feed that data points to machine learning model, and then machine learning model will learn those differences, and then it will learn the difference between the wolf and dog. Same is with deep learning, but there is one issue. There is only one issue when it comes to deep learning, that is also image recognition. Yes, there I agree. There I agree that yes, it you know it might be challenging for image processing model, and yes, it is challenging. It's not like it might be challenging, but it is challenging for any deep learning model as well to compare two different animals coming from related, the cousin species. Okay. If two animals are coming from cousin species, uh, then it is little bit coming from a same family, then it is little bit typical to analyze. Okay. But when it comes to the machine learning, we actually give all these things to, yes, we give all these things to, acha, okay, chalo. See, if I just compare a normal dog with normal wolf, generally a wolf is bigger than a dog, right? So if I will give this particular data to uh, machine learning model, okay, if it is of more than 2 meter long, then that is wolf. If it is less than 2 meter, there are high chances that it is dog. Okay. But if I'll just click a picture, if I'll just click a picture of both wolf and dog, in a picture, you cannot actually tell who is bigger, right? Just by looking into it. You cannot say that. Okay. Yes, you'll try to compare with it with the background and all. But what if I give you the same background? Not even same background, means plain background. What if I give you the plain background? Then you won't be able to tell me that who is less than 2 meter and who is more than 2 meter. Okay. There are few animals then that you can definitely can say that if I just take elephant and all, giraffe and all, lion and all, but when it comes to these kind of species, just by looking into them, it's little bit typical, and then it depends on the engineer as well, like how it is basically processing the model. Okay. By the way, nice question, yeah. Who asked this? Tejas. Thank you. Thank you for asking this question. I hope this answers your question, Tejas. Sure. So now let's continue with reinforcement learning. Yeah. Thank you, Tejas. So reinforcement learning. You know reinforcement learning very well. Reinforcement learning works with uh, like reward and penalty. But if you guys have studied my first lecture, or you guys are, quite intelligent people, and you guys have gone through all these concepts, few of them were really confident, are really confident. So can anybody tell me the, any example where we use reinforcement learning and how? 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 Self-driving car, how? Games. How come you said games? Instagram or Netflix? Instagram or Netflix? They are not they are not reinforcement learning. It's not reinforcement learning. Recommendation. Okay, recommendation system. Okay. When the main guy needs to do mission in games, so what happens then? Chessbots, they learn by their mistakes. Google Maps, finding shortest path. Yeah. Okay. Self-driving car learns using reinforcement learning by receiving rewards for safe actions and penalties for mistakes. Yeah. Math score prediction. Math score prediction. No. Math score prediction is reinforcement learning. No. How? As per the market stipulation and model flows. Chalo. So yes, most of you are correct. So I won't, spend much time on this because you already know. Okay. Uh, it's like, it's like it works on reward and penalty, right? You know the answer. But if you guys have studied in my section, in my first session, or prior to that, somewhere, what is this penalty and reward? What is this penalty and reward, everyone? In theoretical like way, we can simply say, yeah, penalty and reward, penalty. But what is feedback, guys? This is all about mathematics. Answer like an engineer. This session should be like all the people are techies. Conversation should be in technical terms. Yes. Positive points for good action, negative points for bad action. Nirmal, yeah, it is correct. Yeah. Chirag. Chirag is somewhere correct. I won't read it what he has written, but Chirag is somewhere correct. Yes, it is. Is it going right or needed improvement? Like, you are asking me or giving the answer? ChatGPT is the example. I'm asking like how what is reward and what is penalty? Tell me in technical terms. What is reward and what is penalty? It is as simple as this. You guys are actually explaining me. You guys are actually explaining me कि Aman, reward is something that it will get when it will do something right. Penalty is something that it will get when it will do something wrong. I know that. I am saying a reward. Okay, okay. For me, this is the reward. Okay, this is my mobile phone. Okay, for me, this is a reward. Okay, for me, this is a reward. So, if for me, if this is a reward, if I'm doing something really good, and for me, the penalty could be somebody can, just take this device away from me. This can be a penalty. Or somebody can, just, break it. Somebody can just, you know. So okay, reward and penalty depends upon importance. If something is important to you, if something is relevant to you, if I'm giving you that, it is reward. If I'm taking it back, it is penalty. What is giving, what is taking back? Machines. For machines, what can be a reward? What can be a penalty? How machine will understand that this is reward and this is I'm getting penalty? Yeah, Vishwajit is somewhere. Okay, he has reached somewhere. It's good. Now I am starting getting answers. Yes, it's good. Okay, so who was the first person? Chirag. Chirag said for the first time. Zero means can be penalty and one can be a reward. Right? Zero can be a penalty, one can be a reward. Right? Right? And then Vishwajit, well, I think he was Vishwajit only. Yeah. Negative and positive numbers as reward and penalty respectively. Not respectively, means negative numbers as penalty and positive numbers as reward. He might be mean to say this. It's okay. So reward, okay. But the interest, I said it's number, sir. It's a number, sir. Yes, Raj. No, actually. So yes. So now this is where it comes. But still it is not correct. Guys, this is interesting. When we say, now you guys are saying, okay, I'll give you one if you'll do something good. I'll give you zero if you do something bad. Nice. Okay, understood. Computers understand numbers. You are giving exactly in binary codes. It will understand, it will work. But what do you think? Like, what are these numbers? These numbers are points. Do we call them points? What do we call them? What do we call those numbers? Feedback signals. Yeah. Meet. Meet is somewhere correct. Manish is also somewhere correct. No Shesh, no Kirtan, no Nakshi, no Mannan. Tokens are somewhere different. I don't want like a dish. No, I don't want these kind of answer. I want exactly the right answer. Acha, chalo. I'll just show you one example, then you'll automatically will tell me. Do you remember this? Do you remember this? Yeah. Hmm. Do you remember this? Can you now tell me? Can you now tell me what are these numbers? Everyone. Hmm. Yes, Tejas. Yes, Pujan. Hmm. Yes, Darshan. Path? Error? Where is error? Vishwajit. No, this is not correct. Diksha. Yes, correct. Okay. So, guys, everything. Okay. What does AI do? AI take decisions. How you take decisions? You take decisions based on priority. If you want to take a decision, you need to just create a hierarchy of priorities. And then you have to take the decision based on that priority hierarchy. In some conditions, that hierarchy will change. In other conditions, again it will change. In other condition, again it will change. In other condition, again it will change. And that is the crux of AI, right? Why we are using AI? So that in any condition, this particular model will work. So for us, that is priority. For AI, for ML, anything that is under AI, it is weight. It is weights. It is parameters. Always do remember this. Okay. Why I am actually taking, all these silly points, why I'm picking all these, points, because interviewers ask these type of questions only. They know that you know the definition of machine learning. Okay. So many people might know the definition of machine learning. Few people might know, let's say half of the people might know the definition of the types of machine learning. Less than that might know the types of machine learning algorithm, types of machine learning, like the definition of types of machine learning, sorry. And then less than that, there will be people who knows the definition of algorithms. And then only few people will know the exact concept clarity of the machine learning algorithms. Okay. And this is how they pick the candidates. Okay. So please do understand, do learn the things. Guys, it's AI, it's computer science, it's mathematics. You cannot just read, you cannot just go through it theoretically. It's like it's a computer book, and I'm just just learning the question answers. And yes, I know AI. No, no. Okay. So this is about reinforcement learning. Though we have already understood all these the reinforcement learning and all, still see. So please never ever think that you know the things. Can we say that reinforcement learning is most similar to AI out of all ML algorithms? No, like how come you say that AI it is most similar to AI? Because all these things are coming under AI only. Machine Everything under machine learning is coming under AI because whole machine learning is a part of AI. So we cannot actually say that. I know, like you are trying to somewhere, relate all these things to the definition of AI. It's good. This if you are understanding in this way, it will work. But gradually, when you will understand the concept behind different things, once you will start learning MLP, multi-level perceptron, Then you start learning, CNN, then RCNN, then YOLO, YEVO, lot of stuff. Then you will understand that almost everything is under AI. It is the correct definition. Chalo. So now, next definition is semi-supervised learning. Can anybody tell me what is semi-supervised learning? So the semi-supervised learning, if you don't know, I can tell you, the semi-supervised learning is interesting. Okay, it's like it is the supervised learning only. It is supervised learning only, but only when we don't have much data to be trained on. Okay. If we have enough training data with labels, then we call it supervised learning. But many times when we don't have labels to put, okay, and it's really costly to do that, then we use semi-supervised learning. Okay. Yeah, combination of both supervised and unsupervised. But okay, but mostly it is related to supervised only. Otherwise, it can be called semi-unsupervised, right? But actually, it is semi-supervised because we want that particular problem to be solved with the help of supervised learning. We want to be, to have that problem to be solved with the help of supervised learning. But due to some limited label data, it's not our choice. It's the situation's choice. It's a destiny choice that you are not having enough label data, okay? And or you might have you might have the data, you can purchase it, but it's too costly. In that case, you need to play around, with that limited label data only. Okay. But if you will only train based on that, suppose you are only having 10,000 rows of label data, but you are having 50,000 rows of total data and only 10,000 has labels. So what you will do? Either you can shift to completely supervised learning and say, sir, Aman, I will only train based on those 10,000 rows. I don't know any other thing. Okay. I'll just simply take 8,000 rows as training data, 2,000 rows as testing data, and I'll just train my model. But do you think it will be really useful for other 40,000 rows as well? Total there are 50,000 rows. So will it be okay that if you only train with 10,000 rows? No. In that case, you need to shift yourself to semi-supervised learning. It's not like the problem statement has changed. Mhm. Problem is problem. It can be, and it is asking us to get it solved with the help of supervised learning, but it might be costly. It might be limited. If something is costly, it might be limited. Simple. Okay. And one more situation is it can be applied only when the unlabeled data also holds a valuable information. Means it is under condition that you will only use when you have limited label data. You will only use when you have domains with high labeling cost. Third, you will only use when your unlabeled data means even if you will just take those 40,000 rows that are not having labels, then also it is having really valuable information. Then in that case, you use semi-supervised learning, right? Hope you are getting the point, everyone. Okay. So this is what it is. Okay. So semi-supervised learning combines both supervised and supervised approaches. It uses a small set of labeled data and a large set of unlabeled data for training useful. when labeling is costly and time consuming. ठीक है? Yeah, time is also a factor. Time is always a factor. ठीक है? So, sorry. तो चलिए, ठीक है? Let's see. Now, types of now types of algorithms. Okay. So these is the main crux behind your whole machine learning. This is the main crux behind your whole machine learning because this is actually machine learning. Whatever you can see here, this is actually all about mathematics. Every single word contains, you know, uh, almost a book of mathematics. Anybody can write a book of mathematics on mathematics on any of these topic. Okay. Okay. Right. So now you know linear regression. Hmm? Linear regression means there is a line that is trying to understand the pattern. Okay, where are my data points where I can, you know, uh, where I can reach a position such that if distance between me, distance between the line and the data point should be minimum. So with the for the minimum loss, this is the main priority for any of them. Okay, just like linear regression. So okay, so sorry. So now there is polynomial regression, then rich regression, lasso regression. Okay. So don't worry, we won't deep dive into it right now. Okay. We have the separate sessions for supervised learning. We have the separate sessions for unsupervised learning. Okay. So we have all separate sessions. So no need to, worry about that. No need to worry on that part. Okay. So now linear regression, multiple linear regression. Okay. Polynomial regression is interesting. Can you tell me something about polynomial regression, everyone? What is polynomial? Let's start with basics. Let's back to class 9th. Can you tell me what is polynomial? Can you tell me some examples of polynomial? What's polynomial? An equation with multiple variables is polynomial. More than three variables means x plus y equals to 3. It is not polynomial. Raj, is it? Yukti, algebraic expressions. Algebraic expressions. Okay. Okay, so x power 1 upon 3 plus 2 equals to 0. X की power 1 upon 3 plus 2 equals to 0. Is it polynomial or not? If yes, how? If no, how? If yes, how? If no, how? Because the answer of this particular question, what is polynomial, actually explains the need of polynomial regression. A linear equation with power, Goswami, then how will it be a linear equation? How it will be a linear equation, not regression? Which data is not in linear form? Are you sure? जय जगदीश भाई, प्रजापति जी, is it correct? Oh no, you are not there. Who was it? Who was that? Yeah, Sahil. Sorry. So when data is not linear from Okay. No, it's not like that. Mm, Okay, so x plus y equals to 2. Is it polynomial or not? Is it polynomial or not? No. No. Seriously. If it is a guys, it is a polynomial. The condition for the condition for polynomial is okay. I'm getting really interesting answer. That's why I'm smiling continuously. Okay, so now I got the one interesting. Most of the replies I'm not. I'm just reading and smiling. I'm not reading it for you. I can just see it, but only few chats I am reading that are relevant. So Nirmal is saying a polynomial requires all variable. Ha, exactly, Nirmal. This is what I wanted. If you want an expression to be polynomial, the simple condition is variable should have non-negative power. Let me make it more correct. A variable should be a positive integer. Okay. Positive or zero. It will work. A variable should contain a whole number. Okay. Okay. Yeah, whole numbers. Exactly. X power anything is polynomial. No. No, Sonu. This is not the correct definition. The correct definition is any expression that in which the power of variable is whole number. That is polynomial. If the power is negative, then also it is not polynomial. If the power is in uh, decimal form, then also it is not polynomial. Okay. Now let's break this loop. This is not mathematics class. Okay. So actually, in my initial years, like when I was in college, I worked for few IIT JEE coaching, okay, as a instructor, as a teacher. So IIT JEE is still there in my mind. So, but why I am asking polynomial here? I can just simply explain polynomial regression. And why you are so in love with this polynomial regression? Point is, point lies in Vishwajit Rai statement. Poly means many, nomial means terms. Good one, Vishwajit. So poly means many. Many means the power of variable should be more than one. The first definition of polynomial is correct. But when it comes to polynomial regression, the second definition is important. Vishwajit's definition. Okay. Yes, the poly means many. Means the power of that variable should be more than one. And when the power of variable should be more than one, then how will be the curve? How will be the curve look like? For any linear equation, what should be the power of variable? For a linear equation, what should be the power of variable? One. Yes. And for polynomial regression, the variable power should be more than one. Polynomial regression, not polynomial equation, a polynomial expression. Let's forget that definition now. I'm talking about polynomial regression. Okay. For polynomial regression, it should be more than one. And how will it impact to machine learning model? To actually train on some irregular data. Suppose there is a data that is something like this. Okay, something like this. Okay, chalo. Uh, okay. See, something like this. So can you see this, this flow? If you will see, if you will see the flow of this red data points, it is somewhere linear. Somewhere it is linear. But when you will look into the data points of black data points, basically, it's something like this, curve. The curve will be, the curve will suit better. Okay. If you're not getting it right now, let me reshare my screen. Let me use pen and paper. Okay. Just a second. I'm just okay. Just a second. I'm just resharing. Okay. So for this particular, we are putting this line, right? We are putting this line. Sorry, yaar. Uh, array. Okay, let me. I can't actually remove it. Eh, okay. Chalo. Okay. So this is how it looks like. But do you think that for this will work? Do you think for this particular, it is okay? Do you think for this is okay? Hmm? No, right? For these type of situations, even it can be a debate. It can be a debate that whether this is like the linear uh, regression is okay or not. This can be a debating point. Okay, debatable point. But then there are some conditions when, like, see here, you can simply put the line. But what if the point might be like this? What if the points might be like this? Let me put more points. Do you think this line is the right answer for this? Do you think line is the right answer for this now? See, this is the line. Do you think line is the right answer for this? No, right? For this, what is the right answer? The right answer is, just a second. For this, the right answer is, array. Okay. For this, the right answer is, I'm just drawing it. This. Sorry. Right? Okay. So this is the right answer. Okay. So how you can just for this, okay, for this you can take a simple uh, y is equal to mx plus c. You can see my screen, right? I'm just writing the equation. Is it visible, right? Right? Yeah, thank you everyone. But for this, it should be something like this. Okay. Okay. It should be something like this, right? And this is where the polynomial, sorry for the writing, guys. Polynomial regression comes. Okay. Yeah, cos x can be cos x, sin x, whatever. Right? So this is how these different mathematical operations and algorithms works with machine learning. Okay. Okay. So this is the reason. I hope you're getting the point, everyone. Right? I hope this is not going above your head. Chali. Okay. So now let's discuss something about feature engineering. Okay. See, shortly we will discuss about each and everything. These Rage and Lasso, these are nothing but regularization. Okay. Then there is SVM, then there is decision tree. So we'll discuss about everything. Okay. What is feature engineering? Okay. So the feature engineering it's a process where you basically select some really good features. If they are present, then only you will select. But it might be the possibility that it is not present. It is not present, but you have to create it. Okay. First is selection. If it is already present, select it. If it is not there, create it. If it is there, but it is not that helpful right now, but it can be more helpful, modify it. Okay. So select, create, modify. Okay. So like input variables or data to help machine learning models learn patterns more effectively. Okay. After all, we want the features, we want the columns, we want the attributes, we want the dimensions. The names are different, but meaning is same. Columns. Used for sometimes it is used for columns and features, attributes and dimensions. Okay. But for deep learning, they might be different. Okay. But for deep learning, it is little bit typical. Okay. Sure. So So what does this involve? It involves transforming new data, raw data into meaningful inputs that improve model accuracy and performance. Okay. So how it will basically like improve? How it will basically improve? So it will improve when you will understand a problem statement and you will have and you if you have a really nice domain knowledge. Unless you are having a domain knowledge, you cannot be a really good machine learning engineer. Okay? For being a good machine learning engineer, you should be aware about you should have some domain knowledge. Then only you will be able to do some feature engineering. Okay? So if you want to be in this particular field, start learning about different stuff. You never know which domain is waiting for you. Okay? Chalo. Then, what are the processes are involved in feature engineering? So the first process is feature creation. Can anybody tell me, or anybody can give me the example of feature creation? I think I already told you. I think if you know the answer, you can just give the other example as well. If I missed it in last sessions, you can just tell me how feature creation can be done. First of all, how you can create a feature. Feature selection is easy. Like if you have a column where there are so many null values, if the data is distorted in that column, you can simply drop it. You cannot select that column, or you need to modify it. But when it comes to feature creation, yes, Darshan, correct. Darshan remembers the last example, right, Darshan? Okay, Sawmill is also correct. But can you give me an example for this? Darshan has given me an example. What about others? Tail is long and short. No. Aggregating many columns into a new column. Aggregating many columns into a new column. Many columns. Yeah, it can be done. Okay, so now you are telling me how it can be done. I am saying, can you give me an example? Just like I got one example from who? Darshan. Yes, Tejas also. So most of the people are giving me the same. Yes, Zeal has given me really nice answer. Yeah, Zeal Bhatt. Good one. Tabriz. So the best answer, okay, so the most common answer that I'm getting here right now, I don't know, like I generally used to give that example. Uh, that is BMI. Like for the people, if you are having two columns, like co- first name and then two columns, name, height and weight. But with the help of height and weight, if somebody wants to have a really good feature, new feature, fourth feature, one is your name, second is height, third is weight, fourth can be body mass index. So you can create with the help of height and weight, you can create body mass index. This is feature creation, right? This is feature creation. Now, feature transformation. Can you tell me what is feature transformation, guys? Can you tell me about feature transformation? Deepfake is an example. Feature transformation. No. Hmm. Converting a features data from, okay, Raj Patel is saying, converting a features data from one format or scale to other format, make it more suitable. Okay. For chosen algorithm like encoding techniques. Hmm. Yes, this can be the answer. This can be the answer. I agree. Okay. So basically, just a second. Hmm. Okay. Okay. So car color is a feature. Red is 0. Green is -1. Green is 1. The phrase is saying change feature in better form. Mm-hmm. Just a second, guys. Just a second. You can continue, please. So change feature in better form. One hot encoding numerical embeddings vector transformation of images like that. No, that is not feature transformation. Guys, I actually, but you know what? I actually told you what is feature transformation. What if I say I actually told you the feature transformation? Guys. Scaling, right? Scaling. Okay, there was one person who said something. Encoding. Okay, this is how you transform the feature. Means, example. There are so many times when your data is skewed. Do you know skewness of data? Do you know skewness of data? Do you know skewness? Skewness. Skewness. Skewed data. Skewed data means biased data. Means. Let me tell you. Uh, yeah. Skewed data is something like this. Okay. I'm just skewed data is something like this. Okay. This is skewed data. This is right skewed data. Okay. Okay. So even this is better. Some data can be like this. This as well. Sometimes data can be like this as well. Okay. So to deal this kind of conditions, sometimes we use, okay, let me ask this question to you. What you will do if you have one column with this kind of distribution? What you will do? Machine learning engineer question. What you will do if you find this kind of feature, you cannot even do ChatGPT. Okay. So what you will do if you find this kind of situation? There is a, okay. So whatever you will do, that will be called feature transformation. I hope you are getting now. I hope you are getting. Whatever you will do to sort this thing, it will be called feature transformation. Got it? No, no, Chirag. It's not a mean median mode. No. Okay. Okay. Normalization, encoding, scaling, these all, these all are the different, there is one more transformation. Actually, nobody actually has given me the answer right now, or till now, that what you will do if you will face something like this. Okay. Ah, yes, I got something from Tejas. Okay. So the answer is log transformation. And if I and as a recruiter, if I would be a recruiter, then my next question to Tejas would be how log transformation can solve this problem. You are saying log transformation can solve this problem? Yes, the answer is correct. But how? What is the thing that log has to solve this problem? What is the thing that log has to solve this problem? Okay, Nirmal is answering. Okay, Nirmal, then what will happen to the lower values? Uh, I read your answer, but my question is what will happen to the lower values? Okay. So the answer is almost, correct. Okay. A few people has given me the answers. Okay. The answer is, yes, it is correct. Yeah, it's good. Two or three, four people has given me the right answer. It's good. So the answer is the beautiful thing about log is that it actually squeezes a number based on the range. Means if that particular number is too big, it will crush it too hard. If that number is not too big, it won't crush it too hard. Okay? This is the beauty of log. I can't go much into deep, okay, actually, okay. So, but this is the quality. Okay? Hmm. Yes, Raj Patel. A log will normalize the data and stabilize the variance of the data, making the model less sensitive to extreme values. The thing is, I have not introduced variance yet, so let me introduce it. Thank you for putting Raj this. Okay. Now, next thing is feature extraction. What is feature extraction? Feature creation is another thing. What is feature extraction? What is feature extraction? Decoding. No. What is decoding? Like I do have the data now. What to decode in this? What is feature extraction? I'm extracting the feature. Yes, yes, Yukti. Thank you for answering this. It's good. Hmm. Guys, again, please don't give me theoretical answers. That extracting important information from raw data. Of course, the by name it is clear that feature creation means we are creating something. Feature transformation, we are transforming something. Feature extraction means we are extracting something. But how? How? Required to train a model after doing correlation analysis or everything like that in image processing, noted images with annotations. Feature extraction, feature extraction. Um, no. Then what is feature creation? Like, uh, Raj, if this is the answer, then what is feature creation? Jayanandan Kumar Yadav, extracting good data using PCA. Yes. Now you are getting the things. So extraction means when you extract the information. Okay. When you extract the information, and when you extract the information, useful information, and then remove it, you have extracted all the proper pulp of the feature. Okay. You have extracted the proper pulp of the importance of that feature and then removed it. So now you're not having that feature, but you have that importance. You have that pulp. This is feature extraction. And the answer is dimensionality reduction. If you do remember this, if you do remember this, dimensionality reduction techniques, this is the answer. And yes, feature in feature extraction, you can say we can do some average, we can do some mean median mode. This is also a feature extraction. Okay. Now, what is feature selection? Oh, this is easy. Like we can simply uh, uh, check the embeddings. We can simply check the put some filter methods. Okay, like if it is fulfilling this particular requirement, then we will select this. Otherwise, we'll reject this. Simple. It's not that difficult. Okay. Okay. Now I want something interesting. Answers. What is feature scaling? I know you are going to tell me about. No, I won't tell you anything. What is scaling? What is scaling? Why it is important? What is scaling? Viral is saying feature extraction is the process of reducing data complexity and highlight the most important, most relevant information. Yes. Yes. What is feature scaling? Scaling feature is between 0 and 1. Acha? Scaling is always 0 and 1. Basically, making data in one range. कहाँ गया, कहाँ गया? So no other feature can overtake anyone. Yes, I explained you this. Yeah. Thank you. Thank you for answering this. Glad you remember the answer. Um, Arranging features based on their importance. Is it feature scaling? I am saying feature scaling, not feature selection. Scaling means relevant data with good durability. Again, Jay Nandan, please don't answer theoretically. I know you guys are really good with theory part. I know that. But let's now start answering in some techie way. I want some few things in techie way. So feature scaling is nothing but, if you do remember, standardization and normalization. Do you remember these two terms? Do you know these two terms? I am definitely sure you know these two terms. Normalization and standardization. Right? Everyone? These are the scaling methods, na? Min, max scalar, min max scaling, min max scaling, right? Arranging value, range of feature on scale. Yes, Suchit. Okay, guys. So the feature scaling is nothing but to cut down the scale of that feature to very less number. Okay. For example, suppose there is a column where there is a salary of all the people, and there is a column of age. Then there is a column of designation. Then there is a column of experience. Then there is column of the what department, and then the other columns. But when it comes to age, experience, okay, so the column of experience will contain very less numbers: 7, 10, 12, 20, 25. When it comes to age, it might be more than that: 25, 30, 35, 40, 45, 50, 55, 60, anything, right? Till 60, 62, right? When it comes to salary, it will be in lakhs. So we cannot confuse our model to decide the priority. So what do we do? We actually scale down all of them to 0 and 1. Okay. And for this, there are two methods. One, normalization. Second, standardization. Third is also there. This log loss transformation, not log loss, log transformation. Okay, log transformation is something the people use, but they generally use it for that skewness of data. They don't use it for this scaling and all. Okay, yes, Raj Patel. Used for faster convergence in modeling, training, and improve performance for of model by making it compute fast. I think these are all data pre-processing and data cleaning and processing steps, making data model ready for AI training. Yes, yes, Raj Patel. Exactly, it is. Okay, so there is question from Sujal. Arranging value range of feature on scale. No. Oh, sorry. Arranging value range on feature on scale. Huh. Correct. Okay. I thought something else. Okay, so this was all about feature engineer. Now, let's discuss something in detail, dimensionality reduction. Okay, what exactly is this dimensionality reduction? What exactly it is? So, dimensionality reduction is nothing but, dimensionality reduction is nothing but when we have too many features. Okay, so even they are really important features, then also each feature adds some computational power. Adds means requires some computational power. Okay. And computational power means cost. And we have to reduce the cost. We have to reduce the computational power. We are not having infinite energy. We are not having infinite money. Okay. So somehow we need to reduce the cost. Hmm? So to sort this thing, there is a there is a thing that we use, that is dimensionality reduction. Okay. Dimensionality reduction is nothing but that actually reduce the number of features while retaining key information. Okay. Means the information, if you are getting it, okay, if you are getting the information that was 100%, after reducing the dimensions, it is 98%, 97%. Okay, then no issues. If it is cutting down 100 features to 10 features, and the loss of accuracy is only or loss of information is only 3%. Okay, what is the issue? Okay. So when we do feature engineering, at that time we do feature selection. At that time we don't do any, dimensionality reduction. We only select the features based on the importance. Okay. And others we drop them. But when it comes to dimensionality reduction, if we find that yes, in the starting I had 100 features, I dropped 20 features, but still I am having 80. 80 are very important features. I cannot drop them. But what if I just take the relevant information and then drop them, right? I will not explicitly write df.drop, but I'll just, extract the information, then I'll just reduce the features. This is dimensionality reduction. Hmm? It converts high dimensional data to low dimension space while preserving important details. Yes, this is what it is. So if you will look into this now, if you will look into this graph plot, the right hand side, then you will see, then you will see basically right now these all points lie in three-dimensional space: 1D, 2D, 3D. Okay, 1D, 1D, 2D, and 3D. Okay, so these three-dimensional space, the point is somewhere here. So now what you want to do is, instead of these three dimensions, what if we get two-dimensional plane? So can you see this blue colored, can you see this blue colored rectangular shape plane, right? Can you see this rectangular shape plane that is actually trying to cover all the points, that is actually passing just between all the points, and all the points are just around it only. Okay. So this is how dimensionality reduction works. So right now it has reduced three-dimensional to two-dimension. And now we can reduce from these two dimensions to one dimension. Okay. Are you getting my point? What I'm saying? Okay. So this is how we do it. This is how we do it. So if if it's a basic example. Everybody used to give this example only. Okay. But it's easy as well. So that's why I'm giving you this example. Okay. So suppose it's height. Okay. And this is weight. Okay. This is height. Sorry, this is height and this is weight. And you have some points here. Sorry. Okay. And now if you will just draw a line. Okay. And let me make it more better. Okay. So then can you see this projection over here? Right? Can you see this projection over here? What do we call this distance, guys? Shadow, right? Hmm. So So if you plot this information on this single line, okay, if you will plot this on single line, your whole line will have these points, right? Your whole line will have these points like this, like this. See, a single line is having now all the points. And this is how I am actually preserving the information, but from two dimension, one dimension, two dimension, I am only having a one dimension. Right? This is how we actually reduce the dimensions while retaining the information. Okay, this is the thing. Uh, mm, I need to check this, Viral. Like, I'm not the concerned person to ask this question. I need to check this. Okay. Okay. Sure. I'll raise this concern that you have just mentioned. Okay. So this is how we preserve the information. Guys, any doubt related to dimensionality reduction till now? Any doubt related to dimensionality reduction? Everyone. I hope I'm clear. I hope I'm clear, everyone. Any doubts? All clear? Thank you, Raj. What about others? No doubt? Thank you, Zeel. Asif, okay. So tell me doubts, Asif. Please do. I'm clear. I'm here for you. How many dimensions can we use? Uh how many dimensions? See, it depends on the context to context. Okay. We try to reduce the dimensions as significant as possible. Okay. So actually, the data scientists are there to decide. Okay, they actually decide the thing, like how much information loss they can bear, and on the basis of that, machine learning engineers they reduce the dimensions. Okay, so if our information is delivering with the help of one dimension only, then why we need 100? It's illogical, right? It's not like okay, only one feature, like it's illogical. Like, yeah, okay, it is retaining whole information, but it's illogical. No, it is not illogical. If it is having all the information about all the features, then okay, one dimension is okay. But it never happens, though. But just for example, saying this. Is it compulsory to reduce all dimensions to 1D? No, no. Remember, guys. And thank you for asking this, Nimal. Whenever you reduce the dimension, you will always face information loss. Always face information loss. It cannot happen that you are not facing any information loss. So reducing the dimension, you need to actually just for before actually doing dimension reduction, you need to run correlation matrix. First, you need to check how many columns are related to each other, and then you need to create some groups, and then in under those groups you need to uh, do this dimensionality reduction, and then after doing dimensionality reduction with all these groups, you will get one dimension from all the groups, and then you will having a proper new complete data points, and this is how it works. uh, yes, yes, Asif. So like you have told from graph from two dimension graph, we gain one D information. Yes, yes. So how we are getting one D information? Okay, okay. See this. This is how we get one D information. This is how we get one D information. Okay. See, these were the two columns, and we have, see, this was height, this was width. Okay, okay. This, okay. This was height, this was width. Okay, just a second. This was height, this was width. Okay, and now this is our this is our additional dimension. Additional dimension means we are trying to get the information of these two dimensions to one dimension. Okay, so if, okay, just imagine, just forget this line and just imagine these points only. Just just imagine these points only. Okay, so these all points are all about height and weight. Simple. Height and weight. What I'm trying to do is I'm just putting one line between them and I'm trying to get the information on this line. Okay, and then that information would be like this, that you can see here on one line. And then automatically, okay, it will put this whole information to, it will put this whole information to this, see, to this one line. And this is how, this is our, this is how, this is our new dimension. Okay, this is the thing. Okay, Poojan Patel. In reduction, the most informative information we lost then. Uh, no, like, okay. So if you will do dimensionality reduction of, just by taking different non-correlated features, then you will face a huge information loss. So dimensionality reduction only takes place when you find uh, any features that are somewhere correlated. Like height and weight, they are somewhere correlated, somewhere correlated. Then you actually see, if you and me are correlated with each other, means I am having some information that you are also having. So let's merge it. But if I am having my own information, you are having your own information, then if I'll try to merge it now, it won't merge. Even we will lose our information that I am having and you are having. Okay, significantly. And this is the reason we only try to do dimensionality reduction in the case of correlated features. So before this, we need to understand about correlation matrices. Okay. What is it exactly the difference between the dimensionality reductionality and PCA? Okay. So what I just told you, na, this is PCA. Okay, sir. Then what is dimensionality reduction? PCA is a method to reduce dimensionality reduction. To do dimensionality reduction. There are other methods as well, but PCA is one of them. Okay. I hope you got the point now. Sure. Now, What are the advantages and disadvantages of dimensionality reduction? So advantages, the advantage is simply the pattern representation, the classifiers. Faster classifier will less memory consumption, elevate curse of dimensionality with limited data sample. Okay, curse of dimensionality means the more the dimensions, more power will be required, more, you know, cost efficient. Okay, okay, less cost efficient. Okay, so hence we need dimensionality reduction. But in dimensionality reduction, information loss is there, increase error in the result of recognition system. So of course, if you are losing your information, then of course it can put it can put means like it will put your machine learning model in trouble. So you need to take care of all these things. Chalo. Now, what are evaluation matrices in machine learning? Evaluation matrices in machine learning, why they are important? Evaluation matrices in machine learning are important because with the help of these matrices only, you get to know whether your machine learning model is performing well or not. So how you will actually calculate like how okay, whether your model is good or bad? How to do that? So for this, we have some sort of techniques. So the techniques are precision score, AUC ROC curve, okay, area under the curve, okay, receiver operating characteristic curve, okay, AUC ROC curve. Then recall, then F1 score. You can see the formula just below it. F1 score is nothing but 2 times precision into recall upon precision plus recall. And the formula for precision is also there. TP upon TP plus FP. Can anybody tell me what is the difference between TP, FP, T and FN? Simple. This is TP, this is FP, this is TN, this is FN. Can you tell me? Can anybody tell me what is the difference between TP, FP, T and FN? Yeah, like I don't want to know the full forms. I know true negative, true positive, false negative, false positive. That is okay. But what is it? What does that mean? What is true positive? What is true negative? What is false positive, false negative? So Chirag is saying true positive means condition is true and the answer is positive. Hmm. Okay. Diksha, true positive means predictive value and actual value are same. True negative means when machine prediction is true. Actual answer is true. No, 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 Goswami. TN is when prediction is true and actual answer is true. No, Galat. Yukti, true negative condition is true, but outcome is negative. Outcome is negative. What is outcome? Okay. True positive is that value is true and model is predicting it is true. Huh. Actually, it is true. Okay. Okay. So let me put in this way. Most of the people are correct. Some are getting confused. Let me put it this way. True positive means it is, he said, okay, model said, model said, you are guilty. And it was true. You are guilty. Okay. Model said you are not guilty, and the answer was also you are, yes, you are not guilty. Correct. Good one. That is true negative. That is true positive. And then that is true negative. Before that, false positive, false negative. If I predicted, sorry, model said it is positive, but no, this was not correct. False. Okay, this was false positive. Model said, oh, it is negative, but again that was also incorrect. Actually, it was true. You have predicted wrong thing, wrong answer. Hence, false negative. Means the second letters define the model's condition, what it has predicted, and the first letter defines whether it is true, whether model is correct or not. True or false? Are you getting my point? Okay, this is how it is. Second letters defines the models. First letter defines reality. Okay. Second letter defines models. First letter defines reality. Reality model. True positive. False negative. Done? Chalo. Now, there are some challenges in machine learning. What are those challenges? These are challenges, but you know, we will learn all these challenges when we'll pick up the separate sessions for different types of machine learning, supervise and supervise. But for right now, challenges in machine learning. So what are challenges? First is bias, and second is variance. Okay, okay. What is bias? So the bias is, it's an error that occurs when a model is too simple to capture the true patterns in the data. Okay. Okay. Means bias means that tries to underfit the data, underfit the model. Okay. Let's make it too simple. Let's make it too simple like this. Okay. So if you have the high bias thing, but high bias means, what does bias do? Bias tries to underfit the data. Means if we have a model with high bias, means it will try to underfit the data. It will oversimplify the thing. Means even if we have this kind of stuff, oh sorry, even if we have this kind of stuff, something like this. Suppose the data requires is this, but it will only give you this line. This is how high bias works. High bias says, I will only take, I won't take any risk. I will be simple. No issue. Okay? Okay? So we need to reduce the bias, because if we will not reduce the bias, the model will be too simple that it won't understand anything. Okay? Now, variance. What is variance? Variance is too serious person. Bias is too simple person. Lazy person. I won't do anything. So if a person with high bias means he is too lazy. Too lazy means he won't do any work, he won't learn anything. Variance is too, he tries to be over smart sometimes. So if you have high variance, means it will be too sensitive that even a small change is happening, it will capture that as well. Means, for example, where it is? Huh. Even, just a second. Yeah. Even. Okay. Now, any model will be like, any model will be like this. Sorry. If I'll take any model, a useful model, it would be like this. This is ideal. Ideal. This is ideal. But a high bias would be like this. Do whatever you want. I won't learn anything. Just like this. So, high bias. And now, and now it's a turn of high variance. So what high variance will do? It will do like this. It won't lose any sort of issue. So if you can see, can you see this? Yeah, this is what we say overfitting. Means it is unnecessary trying to minimize the risk. Sorry, minimize the risk. Okay, I won't leave anything. I won't leave any data. And this is also an issue because variance tries to maximize, minimize the error. I won't leave any data point. I will go through each and every data point. I will try to solve all the questions. Okay. Bias is too lazy. I will only pick those questions that are right in front of me. I won't go there. I won't go there. Bias is everything. I want this. I want that. I want this. I want that. Okay. And both the conditions are typical. And we don't want both the conditions. We need to minimize the bias. We need to minimize the variance. Both the things we need to minimize. Always do remember. This question is also asked by so many people. Okay. So if you want to understand the bias variance, this is how it is. Okay. So here you can see. So here you can see it has high variance but low bias. High variance but low bias. Okay. Here it has low variance but high bias. Okay. And then there is, you know, so this is, now simply you can say this as well. Low variance, low bias. So we want this. Okay. You can see all of them are missing. So we don't want this. We don't want this. We don't want this. Nothing should be high. Both should be low. Low variance, low bias. And for this, I do have one graph as well. Very popular graph. This. And this is called bias variance trade-off. Means ideal situation is the ideal situation is this. This is our ideal situation. This is our ideal situation. Okay. So we need to keep our model till this. We cannot reduce the variance. We cannot reduce the variance more than this. Okay. Why? Because in this case, it will increase the bias. We cannot decrease the bias lower than this. Otherwise, it will increase the variance. We need to have madhyam mark, buddh, between. Okay? It should be as low as per requirement. And this is our optimal model complexity. Okay? This is our optimal model complexity. Are you getting my point? Okay. So, till now, if you have any challenges, let me know. Okay. Meanwhile, just a second. I'm just resharing my screen. Okay. So guys, I am sharing the attendance link, everyone. Guys, please do fill this attendance link. Okay. Please do fill this attendance link. And then there is a feedback form. Yes, this is the feedback form. I'm just giving feedback form. I have shared the feedback form. Okay. And then attendance link also I'm sharing one more time. Both the links I have shared, guys. Okay. Please do fill it. Meanwhile,